Project 2.1 Digital to Analog Conversion.
Here is the completed R2R DAC circuit. A DMM is connected to the output of the circuit. Notice how each click changes the voltage output in precise steps, each one dividing the voltage in half. So what you're seeing here is the core function of a digital to analog converter, where these switches simulate digital input, and the circuit converts that into a smooth stepped analog voltage.
This video will explain how this circuit works, new concepts learned, and new skills developed.
The prototype requires 7 different components, as listed on screen.
This R2R DAC demonstrates how digital signals can be converted into corresponding analog voltages. It enables devices to translate binary data into continuous analog outputs. The R2R DAC built here uses an 8-bit binary input, providing 256 different combinations of ones and zeros, which are converted into a range of output voltages. The heart of this DAC is the R2R resistor ladder, a network of resistors with 2 specific values, R and 2R. The binary input, controlled by a dip rocker switch, determines how much of the reference voltage is divided and passed to the output. Each switch in the ladder corresponds to a binary weight, with the most significant bit contributing half of the reference voltage, and each successive bit contributing half of the previous one. This creates a stepped analog signal, with the output voltage adjusting as the switches are turned on or off. The dip switch bank controls which bits are set to on or off. When the first switch, representing the most significant bit, is turned on, half of the reference voltage is output. With a 9-volt battery, this would provide around 4.5 volts. Turning on the second switch adds half of the remaining voltage. Each additional switch adds progressively smaller increments, dividing the voltage in half each time. As the switches are toggled on and off, the output voltage steps through different levels, producing a smooth analog output. A DMM can be used to measure these changes in real time as shown here, showing how the output responds to the binary input. The voltage follows the binary sequence, with each added bit having the previous voltage, creating the characteristic stair-step pattern of the DAC. This precise voltage division is made possible by the resistor ladder and the op-amp, which ensures the output voltage remains accurate and stable. The op-amp acts as a voltage follower, maintaining the voltage level while providing enough current to drive external devices without signal distortion. This project introduced many new hardware concepts. The Thevenin equivalent circuit and superposition theory simplified and helped analyze the DAC's behavior. Thevenin's theorem condenses complex circuits into simpler models, while superposition theory helps understand how each binary bit affects the output voltage independently. Additionally, rail-to-rail voltage swing in the op-amp ensures output voltage spans the full range of the power supply.
The permanent build requires 9 additional components, as listed on screen.
Transforming the breadboard prototype into a permanent circuit involved 2 new programs. EasyEDA was used to design the printed circuit board for the R2R DAC, which organizes the breadboard prototype into a more reliable layout. PCBs are crucial for real-world electronics that enhance durability and reduce connection issues. Fusion 360 was used to design a custom 3D printed case for the PCB, which protected the circuit and overall finalized the design. In summary, the R2R DAC works by using a series of resistors to divide a reference voltage in a precise manner based on binary input. Each switch in the dip rocker corresponds to a binary bit, and as the switches are toggled, the voltage output changes incrementally. The op-amp ensures the output remains stable and accurate, creating a smooth, stepped analog signal from the digital input. This process allows for converting digital signals into corresponding analog voltages efficiently and precisely. This is Project 2.1, Digital to Analog Conversion. Thank you for watching.